Welcome back to another video. Let's jump right into the topic of mutually exclusiveness and exhaustiveness. In probability, mutually exclusive and exhaustive are two important concepts for understanding the relationships between events in an experiment. Mutually exclusive events are events that cannot occur simultaneously. If one event happens, it prevents any other mutually exclusive events from happening in the same instance. For example, when rolling a die, consider the events of rolling an odd number and rolling an even number. These events are mutually exclusive because a single die roll cannot result in both an odd and an even number at the same time. Only one outcome will occur. Mathematically, if events are mutually exclusive, their intersection is empty, meaning the probability of both occurring together is zero. This property is essential when calculating probabilities of non-overlapping events, as it allows us to simply add their individual probabilities to get the probability of either event occurring. Exhaustive events, on the other hand, are a set of events that together cover all possible outcomes in the sample space. In other words, when events are exhaustive, at least one of the events must occur whenever the experiment is conducted. Taking the die example again, we can define two events, rolling an odd number and rolling an even number. These events are exhaustive because they include every possible outcome for rolling a die, covering all 6 numbers from 1 to 6. When events are exhaustive, the sum of their probabilities equals 1, meaning they account for the entire sample space. This concept is useful in ensuring that all possible scenarios are considered in probability calculations, especially when planning for every possible outcome of an experiment. In many cases, events can be both mutually exclusive and exhaustive, which means they don't overlap but still account for all possible outcomes. For instance, in our die example, the events of rolling an odd number and rolling an even number are both mutually exclusive, one excludes the other, and exhaustive, they include all outcomes from the sample space. This combination is common in probability models and simplifies calculations, as we can be certain that the events are non-overlapping and that they collectively cover every outcome, making it straightforward to determine the probability of either event happening. Understanding mutual exclusiveness and exhaustiveness is essential in probability, as it provides a foundation for structuring problems and calculating probabilities in a clear, logical way. A Venn diagram is a visual representation used to illustrate the relationships between different sets or groups. Typically depicted as overlapping circles, each circle represents a set, and the areas where the circles intersect show the elements that the sets have in common. For instance, in a Venn diagram with two circles, one might represent the set of students who play soccer, while the other represents those who play basketball. The overlapping area would indicate students who play both sports. Venn diagrams are useful in probability and logic as they help clarify concepts such as mutual exclusiveness and exhaustiveness, making it easier to understand how different groups relate to one another. They can be extended to 3 or more sets, with additional circles illustrating more complex relationships among multiple groups. Thank you for your attention, and see you in the next video.